Hello, hello. All right. We work on linksider. Work on linksider. I did a little bit. I tried setting up dynamic linking so that the linking of the project is faster, but it still is not that fast. Cargo run features, all features. Reset progress, a level. Need a level. Just reset the progress every time. So like right now, in order to compile, I need to wait for the debug build. About 20 seconds, I think. 24 seconds, yeah. Not very good. I think I need to like go and look into that at some point. Dynamic linking. Should be able to fix it if I do it properly. Anyway, what we are working on today. Alright. Today I want to start working on the settings, finally, right? Last time we did this sound effect, where if the button is pushed and when it's popped, a new sound effect. The push and pop sound effect of the buttons. Pretty good. So over here, instead of this being a button to go home, there should be something else. Let's take a look at this thing. Dun, 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 dun. Hello there. Hello, Picorli. How are you doing? I don't know if you heard that. You hear that? Dun, 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 dun. Hear what? Mickey said, hello, Pigorli. From the other room. I think the microphone didn't pick it up because of the noise gate. All right. What do we do? What do we do? I was going to work on the settings. Option menu as pop-up window. Is this the one? It doesn't look like it. Menu mockup. Is it menu mockup? No, this is just menu. Mockup. Mockup has been implemented, but Davey needs to change the graphics so it's not screenshot. Option menu. Wait, where was it? Where was it? Did Davey delete it? There is option menu and option menu. There's two option menu issues. Option menu as pop-up window. Huh? Where was this thing? Remake all the art? Was it here? Oh, it was here, of course. Of course it was here. Option menu. Some art. View is there. Duplicate. Can I close as duplicate? Close issue. Needs to be okay. Well, let's see. I want to do this menu, right? Hello, ICS Boix. What are you doing? There's a pop-up. So I think the settings is going to be a separate thing. Settings.rs. This is your first project in Rust using Raylib. Nice. You want to show? You're Jeff Dev now. Nice. Pro game dev. Okay, so what I want is to have settings. Basically, is going to be just async function settings, and we have the context here, right? This doesn't return anything. This doesn't return anything. We can just This is just the function, right? Like this. Which allows us to change our settings. All right. So the way I have been doing this is going to be UI, right? UI is hard, and there is multiple ways that we've tried doing this. So far in linksider, it mostly has been hard coding. One of the last streams last month was so we were doing the Bevy Jam like 2 months ago or something, right? And I kind of liked the ECS for certain things, and I want to try the ECS for a UI here without the Bevy, but with the ECS, you know? So here's what we're going to do. I'm going to add my dependencies, the Bevy ECS. What is it? Underscore ECS 0.12, right? This is a really small example just to understand how to use it. Let's see. A Rust simple game raylib. All right. So you made you even made a readme of it. You can hover over things and you write the DBG of it. You use WSD, I guess, to move around your red circle. Amazing. Amazing. This is the beginning of something huge for sure, right? Do you have a plan of a game that you want to do? You should practice and then participate in a game jam or something. Where's the next Ludum there? It's soon, right? It's in April, I think. April 12th. 78 days. Raylib is a simple library from what I have heard, right? You can prototype with it pretty quickly. Not sure if you're going to be able to do it in 2 days. First try. But that's fun, so I can recommend. Okay, so Bevy ECS was compiled pretty fast here. That's nice. It's not the compilation, it's the final linking that takes like 20 seconds, which is annoying. Because my binary is like half a gigabyte currently. Anyway, so we have the Bevy ECS, right? And I'm going to have the settings here to use the Bevy ECS. Let's see, Bevy ECS. Use Bevy ECS. They have prelude? They do. They do. Bevy ECS prelude. World. Alright. What do they have in Bevy ECS? If you use just the ECS, is this including the systems? It's not the Bevy app stuff, right? Bevy ECS. Let's see. No, you're only curious about to use things. You have no ambition in that regard. Well, it's fun though. Like, I'm just saying, even if you have no ambition to like release a game, you can have just fun participating in game jams. Still, I still have not released a single game, right? I'm just having fun. Um, you know, even although I plan to release the linksider now, it's still mostly just for fun project. Even though it would be really nice to earn millions of dollars with it. It was an exercise to learn Rust. Do you want to continue using Rust in general? Or do you want, what is it? Is it your hobby to learn languages? That's a good hobby, I think, to learn new things in general. So we have been learning about the ECS, and now I want to try it as part of the game, like as part of the game. I want to try it to use it for one part of the game. Specifically in this case for the UI, for the settings. Boop. Is that not a command? It's beans, I think. One for fun. Thank you, thank you. So Bevy ECS has what? We have components, worlds, entities, systems, resources. So schedules also are here. Schedules run a set of systems according to some execution strategy. Okay. And schedule run on the world. So schedule, yeah, okay. I see. Usually you don't do anything with like schedules, so I'm not really familiar, but now I understand what it is. Component bottles, events. All right. Change detection. Wait a second, while looking at Bevy, I'm going to use Bevy in linksider. Not the full Bevy, but the Bevy ECS, and not for the full game, but for one thing that I'm going to do. I was just explaining it purely. I'm going to be doing the settings. Bevy is multiple things. There is the ECS library, and then there is the engine that is built on top of the ECS library. Okay? It's not... It's going to be both Bevy and Gang, basically. Right? And Genvi. Yeah, bank. Now that's a strange decision. I think ECS is particularly bad for UI. Why? Did you try? Did you try? Why do you have such an opinion? Because I think it's good, but I didn't try. Right? I mean, I tried it for a little bit for the Bevy gem, and the reason I think it's good is because you can split the layouting. You can split, like, parent-child relationships is purely about the layout. It has nothing to do with like a bunch of other things. Like the logic of me clicking on the buttons is like, you can completely separate that. You can completely separate some visual stuff. You can have the buttons be more fancy by, and then that's still going to be like completely split logic, like in separate modules too. So yeah, because ECS allows like splitting the systems pretty nicely, I think it's good, but we'll see. That's why I'm not going to like rewrite the entire game yet, and probably not. Like I want to like try it. If it goes wrong, like I have tried multiple approaches. I think all of them are bad, and I am interested in ECS. All of the approaches that I have tried so far are bad. Okay, like JavaScript approach is bad, or I don't know, Elm architecture is also Like, it's nice, but nah. I don't know. It's I don't know. It makes sense for me right now, but we'll see how it goes as I actually try to implement this. And we'll see how far I go today. It's going to be not a very long stream, I guess, just a couple hours. Yeah. So I'm going to have the world, right? World. So we just do the new here. Yeah. We just do the new world. And what are we going to do? The first thing. So like I have a like a layout thing in the engine, but I think I'm just going to do it here, like from scratch, you know. There is in Bevy also the thing that like parent child stuff, right? I guess that this is in a different library, I think. Right? Bevy hierarchy, I think. Bevy hierarchy. To define hierarchies of entities. Most commonly transform from parent to children or inheriting. Let's add this one too. Or I can do instead, I can do I think what they do usually, right, is we just depend on Bevy, right? Version 0.12, but we do no default features, right? And we specify the list of features directly, which is going to be ECS. Is ECS even a feature? Or is it not? ECS hierarchy. Is that right? ECS. Bevy does not have the ECS feature. I guess the ECS is the default stuff, so just the hierarchy is the feature that I need, right? Hierarchy. Okay, hold on. How do I see? How do I use it actually? Feature flags. Or is hierarchy like the default stuff? Maybe. Like I don't want to use this. I don't want to use anything. It's just the ECS and hierarchy. Okay, you know what? I think what this means is that we depend on just those two crates instead. Fine. Fine. Although even like the hierarchy, in Bevy, it's just like one global hierarchy, right? I think it would sometimes even make sense to make multiple like relations. Not sure though. Anyway, settings once again here. Use Bevy hierarchy. Prelude. There you go. Okay, so we start with making let's start with like two squares on the screen, right? Let's start with two squares on the screen. So world spawn And over here we have the bundle, right? Do you derive bundle? Correct. I mean, I just do a set of components here. Okay. So let's see. I want to have a button that is the close button, right? I've component struct close button, right? So this is just like a tag of what the button does. Maybe it should be like, instead of a tag, like an whatever. We'll see. We'll see. Close button. Boom, 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 boom. Close button. Dot. Let me just think about it for a second here. Um, um, so we still like it's like the in the Bevy UI, it's just like you do the nodes, right? You do the nodes. Um, dun, dun, dun. um, uh, Let me just have something like what I would do in my library, what is currently in game, right? I don't remember exactly, but we would do something like let's just have like two buttons, right? So I would do like a row of two things. A row with button, which is going to say like main menu, right? And button of like close, right? Over here we specify like in you what I have been doing is that you do specify like the action here, right? Like exit to main menu, and this is like the closure that's going to be called, and this something like that, you know, usually. But instead this is going to be like its own system that detects me pressing to this, right? So let's start with just making the row, right? We're just making the row. So we're going to have a component which is going to be called row, right? So this is a row which is going to have a child. Is it spawn child? It's with children, I guess, right? Children, world child builder, row dot spawn close button, right? And row spawn. And there's like multiple ways of like writing this spawning logic in Bevy 2, right? We have close button and we have the main menu button. Activate Linux, no. I'm a pirate. I'm going to use Linux without a license. Spawn. Main menu. Okay. So that's like the very rough idea, right? Obviously this is I need to do something else, right? Because this so like there's two parts of this. Which is going to be like UI library that I'm going to have here. So UI library, so this is like a generic thing that I would probably like want to have in a library somewhere, right? So this is the row, and this is like the user stuff. Component is not satisfied. Use superstar. Okay. Now now what do I want? I want to have a way to, so this is let's start without like any actions, right? I just want them to be like next to each other on the screen, have some like padding between them, right? Have some padding between them. Although, so the way I've been doing it before is that so like Baby uses like the CSS stuff. I have been doing something. If we have a widget, right? Then I want to add padding to it. Then I wrap this into a padding widget with a widget that we want to actually show inside of it. And then if we want to, on top of the padding, add another thing, you know, like some alignment, and we do it like this, you know. So here's so how do I do this? Like it is still going to be like the children there. Row. So if I spawn, this gives me what? This gives me what? Entity world mute. Right? Add child. Child is entity. No. With children. No. How to do? I want a thing like with children API, but where I just spawn one children, you know, one child, you know. I want like a spawn child, so that I can define this hierarchy, which is just like a linked list basically, quickly, you know. That's what I want. Let's see. I can do trade. This world child builder. Spawn. World child builder. Entity world mute. I guess I want to have the entity world mute extension. Entity world mute ext. Function spawn child. And over here we have bundle, impl bundle, right? This gives me another spawn. This gives me, so this is mute self, and this gives me entity world mute, like this, right? So I implement entity world mute ext for entity world mute, right? We do spawn child, we do self dot spawn, wait, hold on, spawn self dot with children, this spawn bundle with children. But this takes a closure, and I cannot return this. Wait, maybe there is something in the baby hierarchy. Documentation. There is literally no documentation of this library, it seems. Spawn. There is a spawn in the world child builder and just the child builder. I know what's different. This is entity command. This is the commands. This is commands, and this is directly on the world, I guess. Okay. So in order to spawn child with children, they spawn okay, I guess what I do here is I'm doing self dot add child, and this is the child entity, right? Adds a single child. If the children were previously children of another parent, that parent child component will have those children removed. Yeah, but I'm doing like a new one. The one that I'm going to spawn. Add child, right? So child is equal to self world mute spawn bundle add child ID, and we return the child, right? This operation is unsafe. World mute. Hold on. So world mute is unsafe. What do I do about this then? So, what is with children? Like, how is with children implemented then? Self world scope. Gives mutable access to this entity's world in a temporary scope. This is a safe alternative to using world mute. Okay. So you have to use world scope. World scope is returning you. Self world scope. World spawn bundle. Child. Can I do this? Lifetime may not live long enough. Alright, how do I do this? A mutable reference to a particular entity and the entire world. This is essentially a performance-optimized entity mute world tuple, which caches entity location to reduce duplicate lookups. Yeah, it makes sense then. While the world mute is, Wait. No, it doesn't. Why is the world mute? Self world mute. Why is this unsafe? Caller must not modify the world in a way that changes the current entity's location. Ah, true. True. If the caller does do something that would change the location, self-update location must be called before any other methods. If I only spawn other entities, then nothing is wrong. Right? I can also do into world mute. This is safe. Into world mute is safe. So actually that's exactly what I want. Right? Self spawn self child. There's also push children. There's replace children. There was something like spawn empty here. World child builder spawn empty. Spawns an entity with no components in the status. So it's over here under row probably, right? Row spawn empty, yeah. I don't want to use this API. This is like weird. I want to do spawn. To use like the chain there. Which probably like going to be looking weird because they are using chaining to like add the things to the same entity. Well, I want to do a different thing. Well, anyway, we'll do self into world mute. This does not work, so we do it not self, we do just self. Like this, because we consume ourselves to do that, right? Then we do self. This is entity world mute. So what's my entity? What is get? This is for this specific entity, right? How do I know what is my entity? ID? Self ID. So basically parent is self ID, then I get the world, right? And then I have the child, which is world spawn bundle, and I set the parent of it to be the parent, right? That's exactly what I do. And that's what I return. But I do child.setParent so that I can return child, right? Because this returns mutable reference to self, not just self. Is anti-world mute? Yeah, okay. So this is what I want. This function's return type contains borrowed value, but there is no value for it to be borrowed from. True, because this lifetime is the same lifetime over here. Right? Born child. Which means that spawn child output type spawn child. I guess I can, or I can like do the lifetime on the trait here too, right? Yes. Like this. Oh, there you go. How it works. So here's what I'm doing. What is this stream time? I streamed earlier today on the Kuvi Boy. I streamed yesterday in the very or early morning. Was that also bedtime? Okay, so here finally finally what I want to do, because I want to wrap my main menu button into something else. So I'm doing spawn and then I spawn child main menu button, right? But over here I spawn like padding. So like for example, if I want to add uniform padding to the main menu button, then I wrap it into a padding. So I can do padding uniform of like something, like, you know, two, whatever. It doesn't matter right now. It's like imaginary units that I'm going to use. Derive component abstract padding, right? So we do left, right, top, bottom, right? Whatever. Simple padding. It's gonna be like public uniform padding self, left, right, bottom, top, right? Like the simple thing. So this is public. Did I check the new style? No, I did not. Should I check the new style? Do you want me to check the new style? It's made for me. Dark theme. Is it only dark theme, or do we have two themes now in the game? Do I want to check it, or do I want to merge it? Only dark? Alright, I guess I can just check it out, though. Git stash. Git checkout. New style. Right? Merge if you like. Okay. Is it only the changes? Toggle bit. Thank you for the raid. Raid and run. Have a good run. Running is healthy. I liked running back in the day, but not anymore. Now I mostly just sit. Good for you. But yeah, I hope you guys had a nice stream there. We're doing some Rust. I haven't been doing programming in a while. So I'm trying to get back into it. I'm working on my game, the linksider, the puzzle game. We're about to check out some of the changes that David did. Which is a dark theme on the game. You guys, just in time for me to show a little bit of the game. Oh wait, hold on. Nunu style is not pulled. I need to pull here first, right? Enter Go PNG. This is the last change. Alright, we're doing Rust game development for those of you who are unfamiliar. We use custom engine, even although over here you see a little bit of Bevy. I'm trying to use Bevy ECS here for the UI. But I'm not going to use Bevy UI. I'm going to try and do my own UI with ECS. Because I have a feeling that that's a good idea. It's not the entirety of Bevy, alright? It's just like the ECS that I'm going to use there. I'm not rewriting the game, Davey. Right. Well, things feel weird here. I guess if you change this, this like looks out of place now on this screen. The level selection screen looks weird. But anyway, here is the new style of the game, apparently. So yeah, in this game, we need to go into the goal like this. Right? Very sweet. I don't like it too much. But I think that I don't have enough experience. The most, like, if I was to say it in just a couple of words, it's too dynamic, right? And the features of Rust, which make it a good language, are basically thrown away because it feels like Python instead when you use the dynamic ECS library. So this game was originally made in Bevy, then we rewritten it, and now I'm going to try it again a little bit. You can show you the new selection. Like, it's too you watched and made a lot of sample games. Yeah, I did Bevy. This game was made for Bevy Jam. That Bevy Jam 3. The latest Bevy Jam, we did another game, but for this game specifically, I didn't like it. And for the last game, I liked Bevy a little more. I think it like depends on the game that you're making. Like, for certain things, I think I like ECS. For certain things, I don't like ECS. Kind of. No, Bevy, I don't think Bevy is hard. But I think it is, it's like saying that, like, I don't know, Python is easy, right? But using it is, and maintaining a project is hard, is what I think. And for same reason, I sometimes I was feeling like that ECS is bad for the same reasons that Python is bad. But it depends what you use it for, I think. Python is only hard as you make it. The more code you write in Python, the harder it is, because Python is a hell. Unless it's just 10 lines. That's what I think. It's too easy to make a mistake there. I want more things to be checked for me. Wait, what is this block? Okay, over here I like it. The colors of the box and the player, it makes it very obvious here that this is like a moving thing and the player is a moving thing. What is this block though? At your workplace, you maintain over 2 million lines of Python and more of C. That would be impossible to maintain if you hear what internet say. But we've been doing it for over 20 years. No, nothing is impossible. I don't say it's impossible. It's like, it's just it's just too easy to make mistakes. Like, you need to rely on some external tools, maybe, right? Like, do you... I guess in today's Python, they have the type descriptions that you can use to help. They added generics in the latest Python 3.12, right? But still, it's nothing compared to Rust. What is this block, Davey? I don't remember. Is this the disable block? I guess it is. Anything else that I want to check out here? Din, 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 din. Disable block is weird. I think it should not be... I don't know. I mean, sure. It's... But I think it's weird. Why does it looks like a bubble to me. You know? Unless you are writing libraries, you never need generics. And you shouldn't use generics if you don't need them. I'm not going to try to convince you that Python is bad. If it works for you, you do Python. Use MyPy, and our colleagues are the ones who started and wrote it. Does linting and type checking, it's very good. You're not saying Python is good, you love Rust. Okay. Alright, read chat. I'm trying to make the disable block just not push. I'm trying out, making the disable block just not push the button instead of pushing the button. And not triggering effects, so it's like water when you touch it. Oh, so like the button is supposed to like go into the block. That is, but how do you do other things that are supposed not to trigger the side effect? This sound effect hopefully will be changed soon. I understand what you mean. Okay. I'm saying people in chat don't be discouraged with Pygame. No. Pygame is very good. If you want to like, yeah, Pygame is good. Like Python is a good language to get started. I just don't think it's good language to stick with. Okay. Um, but if you want to just get somewhere, Python is good. And I want auto tiling for disabled blocks too. It will look better. True. Yeah. I think also like if you making them connect to the actual blocks would be nice. All right, guys, and here's the checkout main. Let's just compare this stash pop cargo run. All right, my compilation times are not very good. I hopefully I'm going to get to fixing that at some point. But for now, we wait a little bit. Hello, Kuviman, you're still learning C++. Hello. How's your C++ learning going? Okay, so if we compare what we just saw to this. So this is the light mode. What do we prefer? The dark mode or the light mode of this game? I think dark mode was kind of nice. What do you think, Davey? Which one do you like more? I don't know. It seems like there is a lot more contrast on the dark. Like the player and like the boxes, they were like standing out much more. I think the background compared to the foreground was not having enough contrast in the dark mode though. The second one, so this one, the light. You'll change the background of dark mode too. I think we need to make it a setting. If it's not too hard. Could be consistently ignoring my PRs. That I am, yes. Alright. Reviewing PRs is work. Imagine working. Do you think, Davey, it's okay for us in the game to have both dark and light mode? Do you think you're going to have a lot more work and you cannot do it? It depends on you, I guess. Did you make it in separate files? Everything is color-coded? But isn't it just the background and yeah, I mean, yeah. We should choose one of them here. So far, one person thinks that it's light mode. I think it should be like dark mode, but a different dark mode. Maybe a little bit. Should my game be light mode or dark mode? Do you prefer light mode or dark mode? Is dark mode good for gaming? Gamers and coders often prefer dark mode for several reasons. First, dark mode can reduce eye strain and fatigue. I think like in general, it's like similar to like it's a puzzle game, right? You're supposed to like stare at the screen. I think it's good if it is dark mode. Why do gamers and coders always use dark mode? What kind of different? I think the biggest thing. Let me just merge this. Did you use it? Do separate files? I want to like so that we don't lose. I mean, we have it in the history, but you have the old, and you have this. Let me merge this. Merge git. There's a cargo lock. How do I accept all? Take a look again. Well, obviously, like the main menu, this doesn't match it anymore, right? We're just looking at the game here, and the UI, obviously, right? Boom, 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 boom. I think the biggest thing is like the background and the foreground is looking similarly. Even in the light mode, they were more different, right? Where is it? The background. there any way for me to projects, linksider, assets, background texture? Frame select view. Brightness, contrast. What if I make this darker? Is this better? Like, you see there is more difference between the background and foreground. Kind of like this is what I'm thinking about. Maybe not exactly this. Let me show you the dark level selection. Show me. Also, in the dark mode, you can see all the ugly... how ugly I cut these buttons from the screenshot of your thing. Can you like fix this? Or are we going to change the main menu? That's why you're not fixing it. Check 205. So this is the level selection. That's good, but this can be done on the existing, so this does not require like too much me coding, right? This is just different textures for the current things and also like showing the numbers on top, right? So on the previous, so you had like the entire preview on top of the button, right? I have to change the grid size, tile size. You mean like we make it to be not square but rectangular, right? That's not too hard to do, yeah. I guess. Also, the preview here is light though. Does it mean that the game itself should be in light mode, but the level selection is in dark mode? I think everything should be in the same mode. How do you expect to see the transition? Currently we zoom into the preview, right? If it's a different color. If this preview is also... Didn't reach the issue title. Preview not done yet. Okay. Okay, sure. But do you agree that there should be more contrast between the background and the foreground here? Because before it was all the same color. This is gray and this was the same gray. Basically. It looks worse though. Okay. But this looks like it's the same. I see that there's a little bit over here, but I don't see the difference between this and this. Anyway. We can get somebody else's opinion, or I can just say that you do whatever you like then. More. I said what I think. We should probably, like, the good idea here is to get opinion from more people. So far, Infinite Coder liked dark mode, and the Liminox liked the light one. All right. You can try asking in Discord. Maybe somebody will get. You can do the voting there or something. We have the linksider as a public, right? We have a linksider general, like over here. You can do something. There's going to be a couple more people that can have an opinion, right? All right, I was doing something though, Davey. I was doing something, and now I have less time to do it. And I was trying to make the settings slowly. I'm trying to play with the settings, not like this. What? Well, it's a decision that you have no idea how many hours you put into finding a better color sets. Right? Well, if you think that this is the best one, then sure. Okay, just keep the current one, okay? It's okay. There is other things that are more priority, I guess. It looks alright. It looks alright. Okay, so I'm like trying here. You are not satisfied yet. Okay. Well, if you like, that's like, okay. If you want to work more on this, then I suggest that you get more opinion from other people. Maybe it can help sometimes, you know. UI row. UI betting. Okay, so basically, yeah. So here's what we're doing, right? We have main menu, and we have a padding around the main menu. So that's why we're doing padding, and as child of that, we have the main menu button. Right? Right. I started using Baby for UI today. I didn't even start yet. This is all code that I have written, 60 lines, okay? I'm just trying to think about it. Yeah. I'm just trying to think about it. Let's say that I'm going to have a system like the layout system, right? The layout system is going to need layout. So this is part of like the library here. So the UI module. This is going to be this layout is the system, and this is going to be querying the how do we traverse baby hierarchy. What's a hierarchy event? Fired whenever there is a change in the world's hierarchy. Okay. I guess there is no like traversing the hierarchy, right? It's just me having no hierarchy query ext. There you go. Iter descendants. Returns an iterator over entities over all of entities descendants can only be called on query of children. So query of children. Reverse the hierarchy breadth first. Inter ancestors can only be called on query of parent. Nah, that's not what I want. So let's see. Query. I want to have the entities, right? This is from Bevy. No. Well, I have both entities in the game, which is a different entity. Entity is ambiguous. Yeah. Why is it a warning that it is an ambiguous? This should be an error. Because of multiple globe imports. Use Bevy ECS entity. Now it's no longer ambiguous, right? It's still saying that it is though, but it shouldn't be. This will become a hard error in a future release. Okay. If I have a globe and both this, a similar name exists in the module. No entity in the root. Ah, there you go. It's just because I didn't load it properly. Okay, so we have a separate layout mechanism, right? And I want to be querying the nodes. So the thing is, if a padding is just like the component, if I want to like a generic system, it should be able to have all of the different layout components, which is like more like I want to have a trait layout component layout like it's a layout node basically, which So like different layout things can happen. I can do a layout self hello Vess. So like my position on this screen is something like this, and I want to lay out the children which have let's have it as slice for now. I want the I can open like my current code, right? I want to traverse things recursively. There, so in my current UI system, we do for layouting, we do two passes. One pass to calculate the constraints of every node, going from children to the parents, and another one pushing down the actual coordinates on the screen, right? So we have two passes. One of them is calculating the constraints, and another one is layouting the children, right? And this is the two passes for the layout node. So there is the actual layout pass, and then there is the calculate constraints self. I guess I need to like have a query of hold on. What do I have here? We have the like we have over here like the layout context or the constraint context. I can do similar things here. But maybe this can already be done in more ECS friendly way. Let's start with the first pass without the second one. So what I want, what is the constraints that we're calculating here, right? I'm calculating the minimum size. And how much we can flex, basically. Right? There is a different layout nodes, which is like padding or this or that. Maybe I can, you know, if there is like just a node that helps me with doing the layout, if this is a trait, then padding should not be the component. The component should be the thing that, so like, there is going to be an implementation of the layout node for padding. You know, and then the actual component that I'm going to have is going to be layout, which is going to inside have a boxed layout create, right? Components also always have to be shared safely. Is there no way in Bevy ECS to have something that cannot be shared safely? Is it only working for syncs and stuff? What's the reason you want to use Bevy UI? UI approach in getting is bad? Yeah, for linksider so far I have been using the hard-coded stuff. In UI, in Gang, it's like I don't know, I just feel like it can be easier, okay? So I want to try it. If it doesn't work out, then I can do whatever else. Have Nursel tried it? No. I think no. I'm pretty sure Nursel also makes. I don't know. Is Nursel here? I don't know how he did UI in his game. Probably hard coded it too. I think it's usually like the easiest way, but I feel like this can also be easy once we figure it out. Layout node. He also hard coded his, yeah, yeah. Layout node plus send sync as beard. Thanks, I guess. So yeah, the actual component is going to be like however we want to lay out our children. Does that make sense? So when we calculate our own constraints, we want to already know the constraints of our children, you know? Children is going to be impl into iterator. But this should be like a dynamic trait object, so I cannot use impl trait here. This should not be a generic thing. Children. Let's have a little slice here for now. Constraints. And this calculates my constraints, right? So beard shaving stream and we release linksider boss champ. Sure. Don't shave the beard until we release linksider. Going to grow big, I guess. Um, Bum, 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 bum. So like over here though, I cannot really guarantee that user doesn't add 2 children for petting, because before what I was doing is something like, you know, I was doing something like button hello, or like just text hello, whatever, you know. Over here we say the action that hello button was pressed, right? And then I do dot padding 1 2 3, you know. That's how I was using it before, which like guarantees that the padding widget only has 1 child. If I do it like this, then I cannot really guarantee it, right? Unless maybe by the way, maybe this is a different thing. So I spawn a child, so I spawn an entity, right, which is like the main menu button. So maybe I should have like the same API then. It's just dot padding 12 is going to basically do another thing at the top. It's going to add it to a parent. And the parent is going to be the padding node. But then I shouldn't use the row spawn, because this spawns directly into the row, right? So that's why the ECS is like, because of the like, it's hard to like guarantee things, but okay. All right, let's just do and then assert here children size, children length is equal to 1. Like the padding node should always only have 1 child, basically, right? And then I would do children 0. This is going to be copy and clone. This is going to be the result. I'm just going to copy it. And then I'm going to do result in size x plus equals self left and self right. The result minimum size y plus equals self top plus self bottom, right? Kind of. Right, and then there is another thing, which is the row, right? The row. So this also is going to have to be a layout node, the row. And this, because this is the row, right? I can copy paste this, I think, kind of. So we have the children. I don't map with get constraints and everything. I do child. So here's what is happening here, right? It's not self children, it's just children. So the minimum size of the row is the sum of the minimum sizes of the children, right? And the height is the maximum height of the children. It's yeah, just like that. So this is me calculating the construct. This is going to be like the first pass of the layout. The second pass of the layout is actually layout pass. So I know myself, and I want the children. I want the children. The children is going to be basically constraints plus mutable. It's not even mutable. It's the. This is where I actually like set. I guess for that reason I had a separate struct, which is like the okay, constraint context and layout context. But let's say that it is the AABB2, so like the rectangle on the screen. This is what I'm going to need to set for every child, right? So once again, children length is 1, child is oh yeah, and also when I'm layouting my I need to know where so like over here when I'm calculating the constraints, we don't know where we are on the screen. When we're doing the layout of the children, we already know where we are on the screen. My position is this. My position is that. So we do children 0.1. This is the child, the mutable reference, right? And we set the child position basically here to be my position, extend to the left, to the negative self left. This is the very simple one. Extend down, negative self down, so basically shrink down. I guess bottom. Extend right, negative self right. Extend up, negative self top. This is simple for the padding. And for the row, let's see over here. Children, iterate, map, child. So constraints is child 0, right? CX position is my position. Self children. Children, iterate, map, child. Child 0 main size x divided by total flex, alright? And then we do for child and children. For child constraints and child position in children. We do width is child constrained minimum size x plus child constraints. I can just do child and do instead of this child 0. Plus size per flex, okay. I'm using F32s now instead of F64s, sure. I don't think it matters. And instead of set position, we do child 1 is it just equals this. At position. All right. This is what I already have. Just like I copy pasted from the engine here, the layouting. So we have the row and we have a padding basically. That's all we have right now. Because I would also like to have the align thing. Right? Query layout box din layout node. Yeah, okay, so in the hierarchy, I have the children component, right? Contains references to the child entities of this entity. Query. Let's see. So when I'm doing the layouting, right? I want to run the layouting on everything that has the. It's been months. Can we activate Linux today? Nah. We still didn't release the linksider. We still don't have the money to do it. So I'm going to query the layout nodes. For every single one of these nodes, I want to know the children. This is baby hierarchy children. Trade bound. Baby hierarchy children where query is not satisfied. Yeah, this should be a reference. Right? So we know for every node, it's a layout node. The layout node has its children, right? And like I said, we have two passes, right? We have two passes. The first pass is calculate constraints. In order to calculate constraints, I'm going to also need to get this entity. And I'm going to have commands. Is my Rust analyzer stupid again? Restart server. So in order to calculate the constraints, I need to sort. And basically, I need to do a topologic sort of all the entities here, right? And I need to go from Is it because the analyzer wasn't written in Rust? No, it was. Was. Why does it fail? Rust doesn't fail. Ugh. Hmm? It needs to unwrap more. Yeah, probably. So, over here, children. So I want to do the top sort, right? It's going to be similar, like the order. I guess I need a queue, mute queue, back deck, new, and also visited, hash set, new. Let's see, for entity in query, iterate. Wait, maybe this is exactly what I want. Hold on, iterate ancestors, right? Iterate descendants. Oh, yeah, this is of a specific entity, but I want to do like a top sort here. I don't even want to do it over a specific entity. I don't even know what the root is. I don't want to know what the root is, I think. Because like I can have multiple UIs at the same time. Like in theory, if I'm doing the UI in ECS, then like in theory I can have multiple UIs at the same time. Like because why not, right? I don't want to iterate the descendants of everything. I want to have a topologic, like the sorted order, so that I go like the children first, basically, you know? Do I even do it with a queue? I can also get the parent here. I can do like the BFS. Usually when I sort, I do a DFS, but in order to not have recursion, I can do a BFS instead, right? So for entity in query iter, I just do if, so I want to have the parent here, right? If parent get if query get parent. So parent also should be like optional, because I don't care if this one is missing, right? Yes, I don't care if this one is missing. So basically, if let's parent is parent, and if query get parent get also is okay, then I continue. Otherwise, I queue it up because this is like the root, one of the roots basically. One of the roots. So technically it's one that doesn't have the parent, but this can be like, the UI can be a child of something else basically. Something that is not like the part of the UI system then. This way, right? So this is me pushing the entity. This is the roots basically, right? Finding all the roots of the UI, right? And then once I have them, I do while some entity is queue pop front, right? Entity, so I do query get entity. Over here I can unwrap because that's where I got it from. So this is going to be it. Entity, layout and children and everything. The thing is, I want to go from down to the bottom. If I do it, wait, hold on. Can you do a D? This way I'm going to have like all the nodes of the UI. I can like store them in a vec, right? Well, I mean, in order to do the DFS, I want to go what should be like here? Or do I like I can also like write a recursive algorithm here. Like a normal DFS instead. Whatever. Let's have the all nodes, right? Let's just store them all in a vec. It's whatever. Let's just do a BFS here, right? Children. And parent that I don't care about is query get entity unwrap. So all nodes push the entity. No. So over here, I'm going to push all the children, basically. All nodes push entity. So this is the BFS, right? And then into the queue, you extend children rate. Like this. Do I even need to do dot iter, or is this implementing? Yeah, there you go. So queue is going to be extended by the children of the current entity. That's like the easy thing. So now we have all the nodes in the order of the BFS, but I want to do them in the opposite order here, basically. So for entity in all nodes into iterator reversed, right? So this is me just finding all nodes, sorted, parent, children. What's this? Function topological sort. Yes. Yeah. Like I said, I usually do it with the recursive. This is like the DFS, right? Recursive one. But I don't know. It doesn't really matter. It doesn't really matter. I mean, okay, fine. Okay, fine. Also, you don't need to have the visited, technically, because we have a tree. We have a tree, so we are never going to visit the same node twice, basically. Right? The only reason for us to, like we are getting the roots anyway, right? So these are the roots. And then from the roots, we want to find this... Okay, fine, whatever. Let's just do this in a recursive way. Right? Lay out, calculate constraints. Let's just do visit. Visit. So it's going to be like the same thing. Kind of. We have the query. I'm going to have a reference to the query here. And I'm going to have like the current node as an entity, right? So instead of doing the queue here, fine, whatever. Doesn't matter. Let's do it like this. A recursive one. I'm just going to visit, query, commands, using the current entity, right? Like this is just the roots, and I'm visiting starting from the roots, basically. And this is our recursive stuff. So I guess yeah, that's why. No. No. Okay. So we go forge. Let's do this. Let entity layout children and parent to be query get for the current node, right? And then we do for child in children. We visit the child, right? Why is this a reference? I don't want this to be a reference like this. So this is all we need, right? We don't even need the visited because this is not a generic like just a graph. It's a tree, right? I basically want though to calculate the children first, and then after all the children are calculated and visited, only then I can calculate the position of myself, you know? So I'm going to have a component which is like UI position, right? So UI position is going to be set using our layout, and before setting up the layout, we are doing the calculating of the constraints, right? UI constraints of the node. I just ripped from a generic learner project. I guess constraints is just I just derive component directly on it, you know? Yeah. So this is our system, and after this is visited, we just do layout dot zero dot calculate constraints, and over here I have the constraints of my children, right? So we have a slice, so it's going to be a vec. Fine. Children is so over here, because we have visited them, we have calculated the constraints of our children, right? And we're going to iterate over them, and I'm going to, for every child, I'm going to query. Well, I guess, hold on, if I use the insertion, then it's not going to work, right? So it's not even commands here. It's not even commands. I mean, this system is going to have commands, but the visitor is not going to have the commands. It's going to have constraints that we have already calculated, basically. It's just going to be a hash map for every entity. We calculate its new constraints, you know? And then you do let mute constraints hash map new mute constraints. So over here I get constraints for the child, right? So over here I can use indexing because this should be already calculated for them, and I can just collect that into a vec, right? So now whatever layout widget this implements the trait, so I can base it on the trait implementation here, the actual calculation of the constraints of this widget. So I'm going to insert into constraints into this node. We have now calculated this stuff, right? Okay. Also, like, the layout mechanism that I'm using here is kind of weird. I can try explaining it if anyone is interested, but yeah, this is the first part of the layouting. I'm going to calculate the constraints. The constraints, all I need for my layouting that I'm doing here is the minimum size and the flexing. Flexing means that I can stretch a widget, and basically if there is like two widgets that both can stretch, it's like the weight of stretching basically over x and y coordinates. So like if I have a row with two widgets that have the weights of 1, that the row itself has the weight of 2 when we stretch, right? Kind of thing. And that's all I need. And would you want it as flex instead of scale? You want me to name it scale instead? Maybe, I don't know why I'm calling it flex. It's like the scaling weight. I thought it was like Flutter. I'm not familiar with Flutter. Is anyone familiar with this? Flutter. Isn't Flutter also has the flex? What is flex? Flex is a no. It's something different here. It's a widget which allows you to control the axis. That's something different. It's like flex, flexbox, and axis-based fill. Yeah, okay. Maybe it's I can like change the name here. Sure. Instead of flex. It's like so like we have the minimum size and like how much we scale according to the like the empty to the space that we have in addition to the minimal size basically kind of thing. So it's not like the scale, it's like scale weight. Sure, I can call it scale weight. It's like longer, but sure. Maybe it makes it more obvious, so it's a good thing, right? So just like size per scale. So here's me layouting the row, right? I'm calculating the total scale of my children, right? And I calculate what should be the size per scale, literally, right? Which is going to be so if when I already know the size of the row, right? I basically divide all of this size proportionally to the scales of my children. Maybe it should just be called like weight. Maybe just weight. Or is it still scale? Scale weight is like two things. Which one of them should I leave here? Scale or weight? You understand what it means now, right? I hope. Zoom in scale because UI scaling is what your constraints and systems was for. Okay. No, UI scaling is usually like the global scaling that you have on your UI. And for global scaling, all I will need to do is to change the dimensions of the root widget. Technically, and it should like do everything that I want for me. Let me just call them weights. Not scale, just weight. Maybe I'm just brain farting, no worries. It's okay, it's okay. No, it's good. I don't know, like, I think flex is like also kind of like weird. It's what's called flex because it was used for flexible widgets. Some widgets are like fixed size and some of them are flexible, you know? That's why I was using the flex name. Because you can have like a fixed size button, or you can have a button that is going to like occupy as much space as possible, like to take on the UI, you know? Yeah, it's like so these are the, I guess it's not constraints, it's like properties. Maybe should be called instead. Maybe it should be called properties instead of constraints. It's like I give I know the properties of the leaf widgets, like of the button itself, right? But for intermediate ones, I'm going to calculate it using like this algorithm that that I do here. I go from children to parents, and I calculate. But yeah, it doesn't really matter. Like, but I like thinking about naming. Naming, I think, matters a lot in coding. With better naming, it's easier to understand the code later. All right. So this is all I need, really. Like, this is the calculate constraints, and then the second part is going to be layout. Layout is going to be really similar, but when I'm visiting, I'm going to, instead of doing it for the children first and then the parent, I'm going to so when we're calculating the constraints, we know we can only calculate the constraint of a parent after we know the constraints of the children. But in layouting is different. We already know where the parent is on the screen, and we are going to lay out the children, and then recursively for each child lay out their children too. So yeah, and also over here, after we calculate all the constraints, we do for entity constraints in. Can I do like bulk insert or something? Commands insert or spawn batch pushes a command to the queue for creating entities if needed and for adding a bundle to each entities. Because it's like a batch here. Bundles iterator. How do I use it for inserting? Bundles iter is a type that can be converted into entity bundle iterator. It can also be a collection. When the command is applied for each entity bundle pair in the given bundles iter, the entity is spawned if it does not exist already. How do I get the entity if it does not exist? Wait, what? Okay, so this already exists. So I literally just do the constraints here, because this is the collection that implements into iterator, and the iterator is a pair of entity and constraints, and this is the thing that I want. And these entities already exist, so I add to all of them. I insert this component if it was not there, or I update it, right? So that's it. And then for the layouting, UI. Yeah, I want to like figure out a better way to do UI. And I don't know, but this seems pretty easy. It's just I'm playing with the. It's a pain. Yeah, I think that's why I'm trying this approach. I think it might be less pain. Have you tried the Bevy UI, Ves? This is not Bevy UI. I'm using Bevy ECS to make my own UI. But this is where I got the idea from when we were making ants. I did a very little bit of Bevy UI, which is UI using ECS. I think it's good approach. But I'm not using CSS like Baby UI. Okay, so we're going to do the same. The layout is this. query layout children. So here, when I'm doing the layouting, I already want to know my constraints. The constraints already have been calculated before, because layout is the second step. The first step is calculating the constraints. The second step is the actual layouting. So I want to actually get the constraints here. In addition. And over here, so we are, when doing the layouting, we are, wait, hold on. Why am I like even doing this, finding all the roots of the UI? I think for the roots, even if I have multiple roots, I still should like somehow mark the root nodes of the UI, because that's how I specify the dimensions of the window. I don't want to like this UI system to even know about the existence of the window or of anything. It shouldn't be tied to like pixel coordinates or anything. I don't like that stuff. So I think there is literally going to be the root node. A root of the UI, and for the root I want to know the position already. So this comes from the user, basically. User says this is like the size of the window. I make it a rectangle. Like I can do just the size here, or I can make a rectangle. Whatever. I do a rect. Fine. Root. So then I don't need the parents here. I only want the children, right? But in order to get the roots, I'm going to just instead roots is a query of roots. That's it. Entity root. It just can happen that I can have this component technically on multiple entities, whatever. Yeah, so I don't even need to find all the roots, right? I just go for root. I don't even need to query the root itself, because I don't care about the size of the root yet when calculating the constraints. I just want to query all the entities with the root component on them. So we do just literally for root in roots. I'm just going to here visit the root, right? Over here I'm unwrapping, so the root should have something. Or I can do... This is okay, right? Okay. Else return. Fine. If it's not found, then we just return. All right, and over here we do same roots. So for the roots, I want to know the actual position, the size of the roots. So we do that stuff, right? Yeah, so this is going to be positions, is for every entity. I'm calculating its position on the screen. So this is the rectangle. So once again, I'm just going for root and root position in roots, right? I'm going to visit the root positions. There you go. And then we do once again commands, insert or spawn batch. All the positions we're going to insert into the world that we have calculated here. Positions. All right, and once again, before visiting the children and doing this recursively, I need to lay out my children here, actually, right? So this, whatever we're doing this before visiting the children recursively. I'm going, so children is going to be a vec underscore. So I want to have the constraints. I'm iterating over children. Child. I want to have query there's some missing parts here. Now that I realize. Because this is only something that has children inside this query, right? Our leaf nodes actually don't have them. On the leaf nodes, I'm going to have probably the constraints component directly, right? So I think leaves is query of the constraints, I think. Leaves. Yes, because the child here is not necessarily one of the calculated ones. It might be the leaf, right? So it's going to be constraints get for the child, or unwrap, or else leaves get for the child. Is this it? Leaves get child. Expect. Child. No constraints. WTF. Dot copied. Oh, I guess I just do a star here. Children is vec constraints. Yes, vec constraints. And the children. Okay. Leaves. Does that make sense? All right, let's go back to the layouting. Positions, insert. So yeah, over here I calculate all the children's here, right? And all the constraints. So hold on. What's the query here? Layout in children. Let's rename the query into the. So these are like the intermediate like layout nodes. Layout nodes. You know, for the layout nodes, I want to know the layout and their children. You know. And for the leaves, I just want to know the constraints. Yes. Layout nodes. For this, I don't need the entities too, right? I'm just ignoring this anyway. So over here, similarly, layout nodes and constraints, query constraints. But the only difference is that over here, I also just want layout and children. So when I'm visiting the node here, I want to do let layout and children be layout nodes get for the node or return children. Can't find value query. Yeah, so for layouting, I want to know the constraints of the children, right? And so this is going to be a vec of constraints and the positions, right? Although I want the mutable reference here because that's what the layout is doing, right? I'm going to do layout dot 0 dot layout my position. My position. So we're going to have my position here too. My position of the root is root position 0. Children. So children iterate for child. So for every child, I'm going to do constraints get for the child, unwrap, and positions insert like I want entry for the child or default. I mean, let's do or insert my position. So like by default, if the layout does not specify, does not actually set the position of the child, it's going to be the same position as the parent position this way. Or insert returns a mutable value. Yes, that's what I want. Collect from iterator. Oh, this over here should be copied. Star. There you go. So I just mutate the position of the children directly. Right? Right. I guess I don't need my position then. I can just say that my position is equal to positions for the node. This should already be there, right? And then finally, we are iterating recursively for child and children. This is different children. Children positions. So we are iterating over the regular children here. Children. We are visiting recursively. Child. Trains, layout nodes, positions. Trains, layout nodes, positions. I don't need my position, but I need to set my position here. Consider removing the borrow. No, this is not copied, right? I cannot copy a query, I think. I mean, maybe I can. Can I? Can I copy it? It's technically just references inside there, right? Cannot mutate. This should be mutable, yes. Maybe I can. Positions into iterator app. So we have calculated here for every node and position. Go to the node UI position, right? Because that's the actual component, the UI position. Visit. I think this is kind of done. So what we are going to have then is we are going to have the root. Let's see again. We're going to spawn the root. So the root can be modified by the user. This is no problem. I can specify where the root is. So I can make this a public field. So it should be like proportional to the window usually. Or if you want the pixel perfect, then you want it to be exactly the size of the window here. Right. I can start with the 0 though, because I'm going to update it on every frame, the size of the root. But the root is going to have children, right? With children. So this is root. And instead of spawning into the world, over here, I'm spawning into the root. So into the root, I'm spawning a row, and it's going to have 2 children. It's going to be a main button with a padding of 2. But this is not a component. Right? And main menu button is a thing that should have like some way to, like, the leaf widget should have the constraint specified somehow. UI constraints. This should be a public thing. I can have some constructors here. Constraints. And for example, I can have fixed size. So fixed size is minimum size equals to the size, and the weight of scaling is 0, basically. So the main menu button is going to have constraints fixed size, let's say 10 by 10, right? And then close button is going to have constraints fixed size, let's do also 10, right? The padding though, okay, so over here the UI is like weird. The API for constructing this like tree, I would like a better one, because like I said, the way it was doing before is I construct a button and then I add the padding to the button instead of constructing the padding widget and attaching the button to the padding widget. I want to go the other way around, right? Best time to plant a tree was 10 years ago. Yeah. Hello there. And also, like, for making a row, I can do like, instead of with, I mean, for the row it's better, I guess, row with children. But for like this, like one child intermediate widgets, I want something different. Can I instead do row with children? I guess it's not with children. Hold on, spawn ID. I guess I can do something like this. Row is, I spawn the row, I get its ID, maybe, you know? But I don't have access to the world here anymore, probably, right? Because I'm inside the world child builder. Root. or the root I spawn. Like, it is weird here. Like, you know, I want to have an API that looks something like this. I want to the row add a child, right? And a child is going to be like something like the button, right? Which is like a bundle, right? And to this bundle of components, I'm adding a padding on top. But this makes it should create like two entities, which is the padding widget, and to the padding widget as a child, I want to have the this bundle, you know, dot padding dot, like, I don't know, align center, you know, and things like that. But also, why the way I've doing it before is the rows also was being done differently. I would instead write something like widget 1, comma widget 2, right? And then like a tuple, because those are different types usually. And then I do dot row, and this constructs me a row instead. But this should instead become like the commands of spawning things. Need to think about like what is the good API for constructing the tree here. Or I can just do like set parent, set parent, set parent every time. So for example, dot padding is the one that's going to I don't know. Let's try this. If I do world spawn, so like over here, the problem is that I'm spawning into the world. I'm spawning into the world, like the main menu button with padding, uniform padding of like 2, for example, right? But the problem is, I cannot have this on a bundle. The spawn takes a bundle. So the spawn is going to return me an entity world mute. And if on this I have an extension method to add the padding uniform, and if this returns me a new entity mute, which is the padding entity now, it's like similar to spawn a child here, right? But I feel that's like different from the existing APIs on the world. All right, let's think about this later. Let's do like this. This is the root, and then I do row is world spawn UI row, set parent root, right? So this is the row. I just do set parent instead, you know. Then main menu button is I do world spawn main menu padding uniform set parent go. And then we do this similarly. World spawn, like close button. So without the padding, we just set the parent to the row. Right? Not spawn, no spawn child. I think spawn child is like a weird API, but it's like it's same weird as a padding uniform. But this I want. Maybe I want it somehow differently though. Maybe I want something completely separated from the world spawn. I can have the whatever. Whatever. Is this good enough? So I construct the root of the UI, I construct the main row, and to the row I add two children, which is the main button of size 10 by 10 with a padding of 2. And I have a close button, which is 10 by 10, which is another element of the row. But this is how I would do it before, is the thing. But maybe I could do it like this, and then like world, like spawn UI, and this is like already like it's like the UI spawn commands or something. The UI spawn tree or something that I can call. Then this would make more sense. But okay, this is just what I want, right? This is what I want here. But what I will do first is without the helper methods. So I'm going to have separately the padding is world spawn. Well, how do I construct this too, right? The padding is padding a component. Should padding be the component so that I can change it? Maybe it should be. But there's going to be a system that, based on this component, updates the actual like generic layout node. Maybe. So I'm going to spawn the UI padding uniform 2.0 set parent to the row, and then I do world spawn of the main menu button, and this set parent to the padding. It's like similar to this, but more verbose, right? This should be .id here. Okay. Now we have something. Captured variable cannot escape fn mute. Mute closures only have access to their captured variables while they're executing. What do you mean exactly? Take a look. Use of moved value layout nodes. Yeah, I think one of the issues is that I tried and I cannot actually copy the queries. And this issue over here. So the positions is a variable that is captured inside my closure here. And I cannot return from this closure the entry. Can I not? Oh wait, I cannot. Yes, because this is a mutable reference. That's true. Because I'm like, I cannot construct multiple mutable references to the same object. Okay. Yeah, that makes sense. That makes sense. I think I'm going to like change the API, this method from being a slice to something else. The layout context like before probably. Then but I guess children positions is going to be back my position with children length. Can I have the length? Yeah, I can. All right. So I'm going to children iterate, and I'm going to zip this with children positions. Mute reference to that. I'm going to have child and child position instead of entry, child position, you know? So like layout text, whatever. Mute, so this is going to be mutable. Right? So after I'm layouting, I'm changing in this vec this stuff, right? And then I'm going to do for child and child position and children iterator zip with children positions. We do positions insert for child position, right? And over here the root position also needs to be done. So positions, or I can find root position .0. And over here we do child position. This is like easier. Fine. This is like my position is going to be part here, my position. I just do positions, insert into node, my position. That. Right? That is done. Private type layout in public interface. Well, yeah, so like the layout here, this is the system layout that's should not be public. Calculate constraints is the system that's not public. Another system that I'm going to have is okay. Maybe don't need to. I can try. Let's do this. Let's do this, guys. Let's write a test because I need to. I didn't do the rendering yet. Let's do test. Test layout, right? So this is what I'm doing here. This stuff. Entity, yeah, spawn child. I think I'm going to delete that too. I don't need that. Test layout. I'm literally going to just have this inside. You know? So I'm doing world spawn, set parent padding, but I want this like I want this to run. So how do I run systems on the world? World run system. This is a system ID. Run stored systems by their IDs. Before running a system, it must first be registered. The method world register system stores a given system and returns a system ID. So should I register a system or should I register a schedule or something? Basically, I want to do something like UI layout the world, right? And this like after I for now I can do this because I don't have like an actual app. I don't have like the cycle update every frame or anything. I just want to lay out the world here. I'm going to set the root to be 00 to 1024 by 768, right? That's what people do. Let's do 100 by 100. So I just do the layout on the world, I think. So this means that I need to register the systems, right? So this is a layout step. And this is calculate constraints step. Those are the actual systems. Maybe system. Layout system. And the public function layout just on the world is going to do world. It can also be run schedule instead. The schedule is fetched from the scheduled resource of the world by its label and system state is cached. For simple testing use cases, call schedule run instead. So should there be a schedule? I have right now only 2 systems and I don't know if I will add more. But it's a system where I calculate the constraints and after that I do the layout. So I don't think it matters anyway, whatever I do here. What if run system? So if I do run system once, then runs a system and applies its deferred parameters. So run system once is a new thing in Bevy, right? So that I don't need to register things. But if I use something like a local, a system local data to cache things, so that I don't need to do like this, whatever, like allocations, for example, something, then it would be nice if I could register it beforehand, right? I guess I can do function register systems world. And then the layout. Then I don't need to do run system once, right? World register boxed system. Similar to register system, but allows passing a boxed system. This is useful in the intersystem implementer. Has already been turned into a system to create object and put in a box. Register system. So we have the calculate constraints system. And we have the layout system, right? Layout system. And then when I run the system, I run them separately. This and then that. Run system. Expected struct found an item. All right, how do we run a system then? Run store system by the system ID. Before running the system is by registered. The method register system gives the system and returns a system ID. Oh, I see. This is different from run system once because it keeps the local state between calls and change detection works correctly. Yes. Yes, change detection might be useful because right now I'm running like these calculations on the entire UI, and like this way I can actually use the change detection and only recalculate the layouting if the window changed its size, or if like one of the or if something else changed, you know. If I do proper change detection instead of doing the layouting of the full tree every frame would be nice. And I think it also like allows to do it a lot easier. The ECS, I think. Run system. So I can have a resource, right? Derive resource, struct systems. It's going to be calculate constraints, system ID, use Bevy ECS system ID, and layout system ID. Systems is systems. This calculate. Hello? Calculate constraints. Layout. World. Insert resource systems. Okay. Let systems world get resource systems run systems calculate. Hello? Does it work? No, it doesn't. Oh, because it's an option. Yeah, okay. Expect forgot to register UI question mark systems.layout. All right. Cannot borrow world as mutable. Because it also is borrowed as immutable. Is system ID copyable? I hope so. Resource copy. Clone. Expect. Star. So just deref here. Run system. Result must be used. Register system error. Limitation. Store system cannot be chained. Store system cannot be recursive. Exclusive systems cannot be used. Huh? Unwrap. Unwrap. Okay, so basically after we create the world, at some point we need to do UI register systems, right? And then we are just going to do the layouting actually of the world. So everything that like has the root and like some constraints on the leaves and some layout widgets inside. Oh, that's what I wanted to do. I wanted to forward like the layout to have these systems. So I guess it is a schedule. I guess it is a schedule that I want to do here. So how do we do schedules? Schedule new. Constructs an empty schedule. You gotta do world schedule. Add schedule. Add a specified schedule to the world. The schedule can later be run by calling run schedule label or directly. So the label is what? Schedule is schedule new. Schedule label. Layout. I mean, I guess, yeah, it's so we have multiple schedules. The layouting schedule, layout, right? Schedule label. Genome schedule label. Layout. Like one of the systems is layouting, another one. I mean, I guess technically, like for the game, all I need is layouting. I think. Mostly, and interaction, and layouting and interaction, and the graphics is like dependent on the game. My UI elements, I think, maybe. Can I do derive? Schedule label. Derive macro for generating impl of the trait. Schedule label. Schedule label is defined multiple times. Could it be instead union struct? Layout. Schedule. Layout. Is this it? Name layout. Layout schedule. This should be hash. Partial ACK. Debug. Copy and clone. This it? So now I have the schedule. Schedule add systems. So this is a regular adding systems, right? Okay, fine. So I don't need the resource like this then. system IDs. I don't need that. I just add the systems. So if I have the calculate constraint system before layout system, does this also register the layout system? Or do I need to register the layout system separately? Dot before. Or do I need to register it separately? So I just do world run schedule. So actually this is a schedule that I can run from outside then, right? Register. Schedule needs to be mutable, world add schedule, right? Run schedule, layout schedule. So this is these two. The other system that I need to do here comes the vibes. Good vibes develops. Hello, hello. How are you doing? I am currently trying to reinvent the way to do the UI, I guess. So reinventing the wheel like always. With the intent of using this for my game, the linksider. I just did the layouting and I'm about to test it as soon as there should be like another system here. Like, you know, register, you know, register layout component. So component T, which is going to be layout node. Register layout node. I don't know, let's make it into a schedule. Because I'm not using the Bevy app stuff, I guess. Use schedule. Right, I'm going to do schedule add systems. So the reason for this, like I will need to like, so for all of my register layout node, for all of my layout nodes, like the padding node, right? I need to convert those into like dynamic trait objects at some point, and so that's going to happen in a separate system, separate system for every type here. So both for both row and padding, I guess. I'm going to add systems. And the system is layout node system. Let's see. I want to have a query. Like it's either added or changed, right? So query is going to be a query of, so like this is for a specific layout node type, right? I'm going to query this component when either it was added or it was changed, right? I guess changed is both for added things, so it's just when it's changed. So I'm going to use change detection here, like this, right? Layout node. So this must be a component. This component always send and sync. All right, yeah, I see. And also static. Value of the associated type storage must be specified. How should this work exactly? Um, okay, I guess layout node is not a component. But maybe in order to register, maybe it's just fine. Plus send and sync. Maybe T over here needs to be layout node and component instead. So this is the system. I'm going to query this. Train bound or changed. I guess it's just changed the filter here. Okay, so I'm querying this stuff. And I want to also get the entity itself. So because basically, whenever my specific layout node component has been changed, I'm going to convert that component to the dynamic trait component. Right? So this means that I need to have commands here. Commands for entity and node and I don't know, layout and query, iterate, commands, entity dot insert layout, and then over here I have a boxed this stuff. So this stuff also needs to be able to be cloned in this case, right? So also clone is required. Yeah, you know, layout dot clone, and this makes me a boxed in layout node. So whenever I'm registering the layout node, I'm going to add the system, the layout node system of this type. And this should be run before the calculate constraints system too. Theoretically, I can do like make a user register their own layout types somehow. All right, we'll figure it out. Does this work already? Something does not compile. Layout not for this. This should be clonable, right? Component clone. Padding should be clonable. Role be clonable. And this cannot be made into an object because it requires a clone here. Okay. I see. So the clone is going to be required instead over here. In addition, I guess. Plus clone. All right, we do the root world spawn. So I have a root widget of 100 by 100 size, and then I have these two. Right. Let's do this. Also UI. No, world run system once. What is run the system once with input? Oh, with a given input. You can have inputs to systems. Run system once. So it's going to be query. Basically, I want over here for my test. Does run system once returns me the output of the system into system out? Yeah, it does. That's nice. So I can have a closure here with a query being a query of the UI position, right? Where we have the main menu button, right? Query single dot unwrap single dot UI position. Oh, UI position cannot be saved, so I can do because I don't want to expose. The user should not be able to modify the UI position. It's the job of the layouting system, right? To have the implement for UI position public function get self. This returns the AABB self. So it's just self 0 like this, right? So over here, single get, right? And over here, just do print out main menu is this, right? And then we find the whatever other button, close button, close. So like this is how we figure out where it is, right? Let's try cargo test, no capture. Layout. I think this is not going to work properly yet. And recognize the option no capture. Is it no capture without the dash? It is. Test failed. We have panicked at no entities 269. So over here, I have panicked because there is no entity with main menu button and UI position. All right. So it means that the layouting didn't work properly, right? So can I do some debugging here? Fine, let's do debug constraints. So they should have a debug inside, right? And over here, I say debug positions. Failed test. So constraint is an empty thing. Which is interesting that the layout, I didn't even get to get the layouts. Am I not so like because the layout system actually so it means that when I say before, it means that it doesn't actually register the layout system. So schedule, add systems, layout. Right? But it is still weird that I didn't calculate the constraints. Hello, what are you developing? Wait, hold on. My chat? My Firefox is frozen. Hold on. Maybe I missed some other stuff in chat? And to kill Firefox. Apparently. What I am developing is a game, but right now I'm working on a UI system. I'm trying to use ECS to make a UI, kind of like in Bevy UI if you have used Bevy in Rust, but not like in Bevy, because not CSS. But I'm making a game. I can show you the game. We didn't show the game in a long time. I'm like, technically I'm not working on the game, I'm working on the UI library for now. But it's going to be used for the game, is the idea. Here's the game. It's called Linksider. You play as the cube and you rotate left and right. And you go into the exit. And then you can attach some side effects on you. And it's a puzzle game. This is just the beginning, which is almost no puzzling. But it becomes hard at some point. And David didn't do the extra in the world selection. All right. Because we're probably going to change it, it seems. So over here, for example, I don't remember how to solve this level. I need to put both of these guys into the goal. After I get into the goal, I cannot do anything. It always was gray? No, Davey changed it. Do you like the gray, or should it be like before? It was white before. Now, and at some point it was also blue. It was blue, yeah. And then the background also was purple. I don't know if Davey is here. He wants to change it. This is Rust. I use my own custom engine. This game is going to work at least on the web, on Windows, Linux, Mac, and Android. Might be iOS. But yeah, I have a custom engine. I like doing custom solutions here. And right now I'm working on a custom solution on the UI here. Alright. I didn't solve this level. Hold on. Let me solve this level. I don't remember how to do it. What level was it again? This one? Unless this is a work in progress level that is not solvable. If I do this... Ah, no, I cannot do that. Hold on. Because I'm going to, like, double jump. So actually... Oh, wait, hold on. So I need to swap the guys here. And to swap the guys. Ah, yeah. Alright. Hold on. This game is actually hard. If I do this, then one of them falls down. Hold on, but I need to swap them. So how do I do this? I don't do this. So like I need to do something similar to that stuff. That doesn't get me anywhere. I need this guy to be rotated again. Where should it be? The jump button should be... Wait, on the left side? If it is on the left side though, I think we are prioritizing. This does not work. Hold on. If I want this guy to jump over this guy can stand with jump side on being on its right, I guess. If the jump side is on its right, What is this level? Is this the unsolvable level? It's called the Whip 7242. Is this the unsolvable level or what? Because of the new mechanics? You don't know? Alright, let's see if it is or if it is not. I should not do that though. For sure. Oh wait, hold on. So it is already in the proper space. So over here I do this, right? This is going to make, after I press left here, make this guy jump to the right into the spot, right? And then I can go back. Alright, no, this level is good. This is hard level, see? It's possible. Why is it called Whip? It should not be Whip, this is a good level. It's nice to solve all the levels again. Like every month I just solve them from scratch and it's always fun. Alright, is this one still possible? By the way, do you remember? I think this one should still be possible, right? You don't know? I think I do this. Nah, I do this. And I go one step higher. And I climb this way. Right? I can climb the wall. I'm almost there. Ah, shit. I just need to rotate them in the very beginning, but yeah, this is solvable. I was there, I just like, you need to do some rotation in the beginning. Kind of miss magnetic. Yeah, magnets are cool. By the way, Dave, you know that this over here, this visual effect that we have, right? You know that you need to draw this sometime? Or do you just are you still figuring out the palette? Mickey misses purple. Movie Man, linksider on itch. Look how purple everything. Yeah, like, why don't we use the purple? Hold on. What's wrong with this? The original. I think the original actually like looks like the colors. Like, what's wrong with these colors? Why don't we use these colors? Again. Look at this jump animation that we had before. Yeah, I also like the parallax on the background, the double parallax. Why don't we have the double parallax anymore? Well, I know nothing about the palette theory, so you probably know better than I do, Davey. All right, you will figure it out, right? It will look amazing in the end, right? Hmm. And schedule. Um. Did you release that game that you were working on, by the way, for the GitHub game of, or the next one? I'm gonna try Form a Purple Filling, I think. Okay. All right, let's see what is wrong here. Register world. So calculate constraint systems before, and I register layout node, padding and row, right? So like, hold on, the root constraints need to be calculated. So does it mean that I could not find a root? I'm querying the entity with the root of the UI. We do have the root UI, right? So this should be like, if I visit this, then I just... Hold on. I don't know, cargo test. Schedule with the label layout schedule was not found. What? UI register? This is registering this schedule, right? With this. Can be run later by calling run schedule label or directly accessing the schedule resource. Schedule resource will be initialized if it doesn't already exist. Encountered a panic in system. Linksider settings UI layout. Wait, hold on. Isn't layout just a function? It's not even a system? Oh, it's the system layout. This is... Yeah, I see it. This shouldn't... Yeah, the layout system is what I'm supposed to register here. There was also a thing like system set. So like in this schedule, we have like the actual calculation and then like updating of the components before that. Right. I'll get better at Bevy ECS at some point. Do we have constraints is nothing and positions is just the root. So I only calculated the root here for some reason. Set parent. Says the parent of this entity. If this entity already had a parent, the parent's children component will have the child removed from its list. Removing all children from a parent causes the children component to be removed from the entity. Parent is the parent is the same as the child. Set parent. Child is self ID. Self world scope warp entity mute parent at child child. So it's basically, hold on. The root has a child, at least one, which is the row, right? So whenever I'm running the layout system, here, I'm at least visiting the root, right? Layout nodes get layout children. So maybe the layout is not there because I am returning here immediately. Maybe layout. No, hold on. Ah, wait, hold on. So the root does not have the layout. That's why it doesn't work. I see. The root doesn't have the layout component. Let's have the root have the layout component. So basically, root is also the layout system. Everything inside the root is going to be just the same, I think. So root, and to implement layout node for root, right? And when I calculate the constraints, it literally doesn't matter what I say here because this is the root. Min size 0 and weight is 0 because it doesn't matter. Well, I guess I can do, you know, constraints on the root is min size is self 0 size, sure, and the weight is 0 because it's not scalable. The root is not scalable, but it doesn't really matter what I say here. And the layout, my position and children, I'm just going to say that for child position and children, I say that child position is equal to my position. That's like the very simple widget, the root. Doing the double here. So then I also need to, when registering, register layout node root. So because root is also a layout node now, right? Root. Root is not clonable though. How do I make this without clone? I cannot. Well, it's whatever. I can clone it. Doesn't matter. I have been working on that game, but this week is all linksider for you. Oh, you are still working on that game? Hold on. So you turned the month-long game jam into what? Are you going to release it before linksider? Okay, so once again, the constraints didn't find anything. But let me make sure this worked. It's not even a working prototype yet. Debug entity. std any type name of t. println detected entity of this thing. Let's see. Let's see what we actually detect here. We should detect one row, one padding, and one root, right? We detected an entity with padding, we detected an entity which is root, we detected an entity which is row. So we have, for all of these entities, for the root, for the row, and for the padding, those should have the components with a layout, right? So that should be working. The next thing is, why do I not calculate any constraints? If I hold here for the root, I visit the root, layout nodes. So I'm querying. This is the so this has the layout inside, and we should have the children, right? Let's go here. Print calculating constraints for node, right? Let's leave this println, but I know that the entity number 0, the first one, is the root. That's the first one we spawn. But we don't even go here. I'm not even coming here. Which means that I don't have the root entity with the root. Does this not work? Calculate constraint systems. Oh, wait, hold on. Why is this? No, calculate constraints is before the layout system, and everything that we want to detect should be before the calculating the constraints. Yes, the detecting. So this is happening before this. So I should have. Oh, wait, hold on, because we have the commands. Commands have not been applied yet, right? So I want a system that applies the deferred stuff, right? Should this all be in one schedule, or should this be like three different? So like I have three different steps, right? First, I find the nodes, the layout nodes, whatever has changed in them. I update the state of the UI system. If that happens, then I calculate the constraints. Then I do the layouting. Is this supposed to be the same schedule or multiple schedules? Maybe this should be multiple schedules. Should this be a separate struct? So should this be a one enum? Enum schedule label. Let's do an enum. We have three steps, right? I don't know. Calculate constraints. Layout. And before that, update, right? Schedule label is defined multiple times. Label. Can I do label? All right, let's do label. Let's do update. Calculate constraints. Layout, right? So no before, no after in this case, then. No before and no afters. World schedule scope temporarily removes the schedule so that it will level, runs user code, and finally re-adds the schedule to mutate. World run schedule, try schedule scope, try run schedule. World add schedule new add systems. This returns the mute. Okay. Let's not have this in a separate thing yet. That mute schedule is schedule new label update. Okay, so we add systems, which is the layout node system. Padding, row, and root, right? Those are the things. This is the first schedule. The second schedule is going to be calculate constraints. This is going to have calculate constraints system. And the third one is layout schedule, layout system. So those are the three schedules that will run in order to do the layouting, right? If I run the schedule, so like this will apply the commands for sure, or I could instead add a system that is applying the deferred stuff, right? Okay, so here we go. We have actually calculated the constraints. So the constraints of the two, so 2 is the padding, right? So for the padding, the minimum size is 14 because we added this size to the 10 to 10, the padding of 2 to both sides, so 10 plus 4. There you go. And then this is the positions of everything. So the root is 100 by 100. The row is 0 to 100, true. And then these two things are from 0 to 14. Hold on. 2 and 3. 2 is padding. So 3 is the main menu button then, right? Two is the main menu button. I mean, 3 is the main menu button, and 4 is the thing. So for the main menu, we actually found its position, but for and the close button was not found for some reason. But the main menu is from 2 to 1298. So we took 100 by 100 Wait, hold on. No. This is weird. Why is it wide like this? No, I know why. I need another widget for this to work, the aligning. For this to work properly. Or I can embed this inside the rows directly. Logic. Child position. Hold on. I can do for the row a little bit differently. Here, like the height should be not my position height. This over here be if child 0 weight y is equal to 0, then it should be child 0 minimum size y. Otherwise, it's my position height. Yeah, like this. So like if it's flexible, then it will take the whole row. Otherwise, exactly the size that it needs to. Okay, but why did I not find the other one? Children. So I did lay out the main menu, but I didn't lay out the setting for some reason. Let's see, in the layout, I visit the child. I just go into all of my children, right? And set their positions. Child positions. I am literally inserting this. For the row, I should... Maybe I didn't set the parent? Oh wait, the close button is after me testing this. It makes sense. Alright. I'm only editing it after testing this. There you go. There you go. I think it should be working, the layouting. The only thing is like to change the different layout, which is like the aligning is the most important one, like and then like row have a way to do the column. Anyway, here's what we have. Here's what we have. So we have a row, right? Which is from 0, 0 to 100, 100, right? We have the main menu, which has a padding of 2 and size of 10, which is why it is located at the position 2, 2 to 12, 12. Makes sense, right? And then because of the padding, the close button is going to be at 14. And 14 and 0, because this one does not have any padding. And over there, yeah, okay. This works. All right, nice. This is the beginning. This is the beginning. So adding new like layout widgets is kind of easy. I already have them. I can copy paste from my previous code. But I don't need like much. Padding, row and column and a line is all I technically need for doing a bunch of layouting, right? So like even this is already very useful, I think. So yeah, the reason I think the ECS approach is good is because I can separate the layouting, the rendering, and the interaction code completely. And that's a good thing, right? Okay. In order to see this on the screen, we will need to actually do the rendering though. So it's going to happen later. And then the interaction too. It's going to be needed. But yeah, this is good for now. This is me doing the ECS UI test. Alright, this is going to be it for me for today. Good progress. Even although not visible yet. I don't know if anyone was understanding what I was doing. But is Captured still live? Wait, what? $7. Alright. Captured is doing some game jam. I'm not sure which game jam he's doing, though, because I didn't ask. But he's doing a game jam in Unity. C#. See you guys next time. What jam is it? Bye.